Been really privileged to be in this project. So this NECOVERSE project, as Nika said, has it's been given so much on the collaboration side, and we've developed so much things. But coming back to Dimitri's topic on inspections, I'll bring you a few kind of sneak peeks what we've been doing. But I think the best thing here is to learn from each other. So my topic is also inspections, but this can also be applied to, let's say, maintenance, logistics, and all sorts of field work, if you say. And when I'm talking about metaverse, I really don't like the word in a way because it's really not specific, but I use mostly metaverse technologies. So there's just many different technologies here. You can see here there's a VR classes, that's virtual environments is one thing, but there's others as well. So first off, I'm Tuomas, I work for Kiwa. So we're quite a large inspection certification company. And I'm mostly focused on new services, new innovations. And what we do, daily work, we have 12,000 people doing testing in, for example, industry, inspections in real estate industry. We do certifications, ISO certifications. We train a lot and we provide digital services. And sometimes we also do technical consulting, but these are the core things we do. I'll bring you a few details on just in Finland, what we do. You can imagine this in global scale, but for example, in Finland, we inspect like 40,000 elevators and lifting devices, 16,000 measurement devices, pressure equipment, cranes and lifting devices, and we have about 650 people doing inspections. So why we're interested in, let's say, remote operations is quite clear that can we do parts of these, or maybe in the future, a whole lot of these remotely. So what we set out to do is we kind of think that inspection work today, if you, let's say I talked with Tony, one of my colleagues, he's a crane inspector, and he was complaining a little bit about the weather of the past month. You know, being in the cranes, the large cranes and all that. Most inspections are done on site. Everyone must travel there. They're mostly periodical, like once a year or once in a 2-year period. They're location based. If you don't have an expert there in Finland, let's say, you can't do that inspection. You have to fly someone there. They demand quite a lot from scheduling from the client, our planning, machine downtime, that sort. And it's sometimes dangerous let's say, if we do inspections in industry. And in many cases, the customer needs to build expensive scaffolding. I have an example here, actually. We use a lot of drones. We use, let's say we have a ball drone, cost like 100,000. We have those large-scale drones, external, used outside. We have crawlers, we have worms, we have all sorts of different devices to kind of use as inspection devices. But still, the scaffolding, if we can avoid that, the customer can save like 40,000 euros. So that's actually the main thing. And today, we still use pen and paper, plan in building plans and all that, many times as PDF, for example. And the remote technology is quite, used not that, common. So in this project, what if in some inspections could be done remotely? So we don't aim to do all the inspections, all the parts of it, remotely, but some we could do. And we can actually do inspections today so that the client is there remotely. So let's say if all the persons have traveled there, maybe just one person travels there. and others are remotely, for example, with wearables and that sorts. Then we are also thinking about where to apply inspections. It's not you can't do periodic legal inspections today remotely, not by a long shot from legal and standard point of view, but you can do risk-based inspections. For example, if we have done once a year, but the machine that we're inspecting is really in high importance, or then it's used a lot. Let's say a crane can be used like 60,000 times a year or 2,000 times a year. So that you should maybe invest in extra inspections. So that those we could do remotely. There's no standard there. If we have remote inspection capabilities, the inspectors can be anywhere in the world. That's important because there are limited expertise in many areas, like NDT. Then, if we utilize remote inspections, we can provide almost instant inspections. Not like we're gonna come there next month and that day, please shut down the whole thing. We can do that in half an hour. So that's our aim. But yeah, the scaffolding things was said and the plans could be accessed. Yeah, the eighth thing that we also kind of wanted to think about in this project, can we actually use not virtual reality per se, but maybe augmented reality could be more useful in fieldwork. So we wanted to understand. And our ultimate game could be, we could do more remote collaboration with the customer, more risk-based extra inspections and monitoring services. So what we set out to do is a few pilots in a NECOVERSE. First off, quite simple, what we can do today with remote collaboration with these headsets, for example. Then we moved on to, let's say, in elevator inspections, what kind of technology we could use there to enable, let's say, the collaboration more with the maintenance and inspections. For example, in ships, if you have maintenance people and they're doing the inspections anyways, if we could be present in some of them and kind of collect information. So maybe we can collaborate there. That's not to say that we will do the inspections that are mandatory still, but if it's a high-risk thing, then we could do that. And then we set out to do a fire safety inspection with AR, with VTT also, and then crane inspection, which is a more complex thing. Our companions in this journey has been Turku University of Applied Sciences have been amazing work with Merja, for example. Where are you, Merja? There somewhere. Yeah. So amazing work. You know, collaborating with this project. Then Chao Yang in that corner, being involved in the elevator inspection and crane inspection. You'll see a few clips there. And then we have Mika Hakkarainen from VTT. There you go. You know, doing really amazing work with fire safety inspection. And now I actually just have videos for you guys, so I don't have any bullet points here. So first off, we collaborated with Kone. This is from Hyvinkää, and there's Nico also from Stereoscape, being in this project also. We wanted to know how we could collaborate with the on-site personnel doing maintenance, for example. So can we collect information? Can we inspect what kind of items we could inspect and what not? For example, mechanical things are really hard to validate, but some things are quite easy. So this was kind of interesting. So that's kind of first stage where we want to kind of understand what's possible and what's not. Then we went on to test 3 things with field inspectors. So here's Nico. He's a remote inspector doing the, collaborating with Tuomo here, who's a local inspector or a maintenance person or a junior inspector. And then we went on to kind of doing the full inspection process for an elevator. And there were many hardships, but I think we did okay. And kind of we tried first just to use the smart glasses here with video and audio feed, so that they kind of use like a Teams, online meeting, so quite low tech in a way, but still there were issues with Wi-Fi and all sorts of that kind of things and that sort. And the next test, here you can see actually when the Wi-Fi is a bit bad, he can't actually validate many things. So one key point for the manufacturers of anything that we want to inspect, please provide a 5G Wi-Fi and it's all good. So that's my message. The next part, you have to have a really good understanding of how to make the inspection process really human, so that, for example, if Nico says something, Tuomo needs to repeat that, and that's sort of really kind of how do you do this, in a concrete way. So here you can see what he's doing. He's shaking, for example, the structure, and Nico is here like, can I actually rely on his, opinion here or not? Maybe not. Maybe if he kind of relies on Tuomo's expertise. But there might be also measuring devices where he can, measure that, okay, that was 1 millimeter, 6 millimeters or whatever. Then we added 360 camera here. Chao built a 360 camera, really low cost, cheap camera here. And now we can see the second person view, what Tuomo is actually doing, not just the view from the wearables, but actually he can see that, is Tuomo in danger of somehow. So kind of having two cameras, don't mind the cameraman, is not going to be, it shouldn't be there, but kind of you can see that now we can validate a little bit more what he's actually doing, not just the kind of, and what's the surroundings there. So this also taught us a little bit on, where the camera should be and what kind of, audio should be there and that sort. What kind of system we need to have when we kind of do these remote operations, and really kind of concrete things that how this could be done in real life today, not tomorrow. Okay, so and the third one we used Nokia Araksaran. Aalto and Chao's team has licenses to test Araksaran, which is a really high definition video feed from the events. So here actually Nico said, he's the remote inspector, that this is quite impressive nowadays what you can do with these kind of technologies, if we have that kind of technology. So he can, be kind of in the space. And if you add, let's say, also the VR glasses so that you can actually be there, it can be quite, in some cases possible. And so this was kind of the first initial stages where we wanted to learn about what's possible, what's not. Okay, then VTT's approach was really, really interesting. So here's Tony. He's doing a fire inspection, and he has these wobbly magic leak glasses here with him. So Mika and his team has been kind of researching, AR solutions. So here you can see he's doing a checkup. He has the map in his hand, and he's seeing about the fire safety devices there. And now he's accessing the AR environment and kind of seeing that, okay, here's a defect. This is okay. Here's a notion. Please keep this in mind, or something like that. So annotations into a real life situation. And in the long run, when you have this kind of information, it also directs the next inspector to be, see everything that's been going on. So quite impressive from PTT's side. So you can do, let's say, all kinds of things with this. But also you have the collaboration side, so that you have the video feed and all that. And you can record things and validate things like that. Okay, so the third one is a little bit longer, but this is quite interesting. So here you can see we're actually inspecting from in Aalto and Chao's team with you have been kind of developing. You have this research crane. It's an overhead crane, quite a big one. So a kind of a system how it could be remotely inspected. And keep in mind, when you're kind of seeing this video, this system could be used for many cases, not just crane, but actually all kinds of devices or structures. So here is Juha, he's a crane inspector, and this was last week where Juha got to experience how it could be in the future. So here's Petri. Petri is also here. Thank you, Petri, also in this project with me, with Kiwa. He's also business development manager. So here, Chao has been creating this system where the manager creates a task of a remote inspection. He selects what kind of evidence is needed. It can be text, it can be video, it can be, drone footage, that sort. And creates a list of what items you should inspect and how. Then there might be a drone operator who, present or not, or we can have a drone in a box solution where there's a drone. These need to be quite cheap ones if you want to scale it. And then you can upload, let's say, the videos, or they can flow directly into the system. And then these will be used by the inspector in the next phase. So first up is gathering the information. Then Juha gets on going with the inspection process, access the crane and the cameras located around the crane. He can access the digital twin here, which is operatable digital twin. So when it moves, the digital twin also moves. So these are connected. Then he can access, let's say he can access the drone, or he can access this cute little robot camera here with a 360 camera view. He can see about the spaces, is it safe to be inspected, where is the crane, how it's looking, is there obstacles, that kind of stuff. Is the lighting quite well, that sort. And he can move the crane with a, because it's a remotely operatable device, he can move it and see how it moves, and from here you actually have the data with the sensors. So let's say vibration sensors, heat sensors, energy sensors, that sorts of data that is kind of used as kind of validating that there might be a defect or not. Here you can see also, if you select these cameras and place it quite well, you can see that if they're placed somewhere that is critical, then you can kind of see that, okay, those stoppers and slowers are, operating quite well. Then he can see about those drone footage and see then, could there be defects also visible? And there, Chao has been also creating with his team kind of AI solutions, to go and to kind of identify the defects. We also in Kiwa have that kind of technology where AI can kind of help in finding the defects. You can actually see where the inspector sees defect that shouldn't belong there. So let's make a note there. It's not a big deal, but this is a big deal. There's a tool there on the rail, so it might even jeopardize the crane, usage. So he writes that down. Okay, so then he moves on to checking the hook and the rope. So he can lower, do things with it. It shouldn't do that actually, so it should stop before the floor. So he kind of sees that, is the rope and the strap, is it okay? And he can access maybe closer cameras. And keep in mind, this system is quite cheap. Well, if maybe if Aalto will productize it, it might not be cheap, but in technical senses, it's using camera technology, quite technologies that's already there. So the sensors are quite cheap, as you said, Chao, that this isn't, you know, something that you kind of have to invest. Well, maybe the Nokia Araxar might be quite expensive. But then when the inspector goes on and creates the report, he can also validate from the sensors that, you know, can I see that the defect has caused something or not? Okay. So how much time do you have?
7 minutes.
7 minutes. Okay. Great. So few key learnings still on these topics. As said, business value is great. Cost savings could be good, but there might be really high upfront costs for the manufacturers. Let's say elevators. Let's say cranes and that sort. So these things have to be dealt with. It might even be that there's you know, providers that provide these kind of systems where it's needed. I would start, for example, in high critical places like nuclear power plants, and that's where it's kind of a no-brainer that you need these. So it might be a slow adoption here. Technology, IoT tech is quite okay, it's maturing. I'm more concerned about, can we access the data as inspectors, and can the maintenance have all the data they need? Wearables are quite there, actually. You can use those, and I would say that you should buy them, and you should buy the software that comes with it. For example, there's Stereoscape, and there's also Softability that has really good solutions there. From our side in inspections, the regulation standards are between making this, you know, inspections a really big thing in a way, so that every regular inspection can have some remote operations there. But we can monitor, we can make those, you know, extra inspections. So there's possibilities. And one key aspect, I would say, that the remote collaboration, just to have the client there in your classes talking to you, that everyone doesn't need to travel, that's okay. If we can do that, that's perfect. And sometimes you even don't need those classes. You can use your mobile phone. So I would start with scalability. There are some change resistance, but where I don't see it with the inspectors, not that much, actually. Everyone who's been involved in this are quite, you know, thrilled, and the enthusiasm kind of bubbles, you know, is this really cool? This is really cool. So, but sometimes when we have tested, there have been really many kind of things that the wearables aren't that easy to use, software isn't that easy to use. Still, you saw that these videos, they made a lot of hassle. So they looked easy, but they weren't. For example, from the Wi-Fi point of view, that's cost like 2 weeks from my time. So I don't stress that too little. Okay. So from my side, I would just like to kind of thank Aalto University, Chao and his team, VTT, Mika Hakkaranen's team, and everyone who's been in this project, from Kiwa and other companies like Vertikkivi and Finbeda, and every one of you. So Linksoft, maybe I didn't name everything, but this has been a really journey. Thank you.